Hello and welcome to this video. This is the first part of the video lectures on trigonometric equations. This is 6.5. We'll be talking about basically four parts, four topics. The first thing is equations in linear form. Second, higher degree equations, but we'll limit our discussion up to second order, quadratic equations. Then we'll be talking about trigonometric identities to solve trigonometric equations, and final topic will be using inverse functions to express solutions to trigonometric equations. So let's start with the first topic, equations in linear form. What do we mean by that? Uh, let's begin with an example. So let's say we have this equation, 2x plus 4 equals to 6. This is simply a linear equation because the unknown variable x is in first power, it's not squared, or any other trigonometric or exponential functions, transcendental expressions are not involved here. So this is a simple example of linear equations. So by solving this equation, we have to find the values of x that satisfies the both sides of the equation. So how do we do that in algebra? We subtract 6 from both sides, we subtract 4 from both sides, and then we get something like this, 2x plus 4 minus 4 equals to 6 minus 4, and then we get twice x equals to 2, and then we divide both sides by 2, and we get x equals to 1. That's how we solve trigonometric algebraic equations. Now, if we have some trigonometric equations like this, sine x equals to root 3 over 2, note here, this is in linear form. Why it is linear form? Because the expression sine x, it is in its first power. There is no squared or multiplication of any other trigonometric equations or functions. So this is the linear trigonometric equations. Our purpose is to find the values of x, meaning we need to find the angle which gives us sine x equals to root 3 by 2. So if we consider from angle from 0 degree to 2 pi, and if we look at this unit circle here, we know that the angle theta 1, if we consider theta 1 equals to 60 degree, or pi over 3, the same thing, we get uh, an ordered pair of 1/2 and root 3 by 2 in the unit circle. And probably we know that the second component of the ordered pair represents the value of sine function. So in the first quadrant we get theta 1 equals to 60 degree or pi over 3, and sine is positive also in the second quadrant. So in 0 to 2 pi range, we have two angles that gives sine x equals to root 3 by 2. So our solution could be something like that, x equals to pi over 3, or x equals to 2 pi over 3. The second angle here, theta 2, that is 120 degree or 2 pi over 3. So these two angles, we already know that these two angles gives us sine x equals to root 3 by 2. If x equals to any of these values, then we'll definitely get sine x equals to root 3 by 2. However, there are actually infinitely many solutions to the equation. That means we can write x equals to pi by 3 plus 2 and pi, or x equals to 2 pi plus 3 plus 2 n pi, where this n belongs to set of all integers. This z includes number negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on and so forth. So we can substitute either n equals to positive values, negative values, or zeros. All the integers. So if we look at the sine sine functions graph. So this is the fundamental period of sine functions 0 to 2 pi, and in the first half of the fundamental graph, we see if x equals to pi over 3 or x equals to 2 pi over 3, we get two positive values of y, that is root 3 by 2, which is equal to 0.87, which is less than 1. That's why it's here. So if we draw a parallel line to the x-axis, we can see that the parallel line intersects the sine function, the graph of the sine function, at infinitely many points. Actually, all these points where the parallel line intersects the graph, the x values are the solutions to this equation y equals to, sorry, to this equation sine x equals to root 3 over 2. So all the x values, first one is root pi over 3, the second one is 2 pi over 3, the third one is 7 pi over 8, 7 pi over 3, the fourth one 8 pi over 3, and so on and so forth. All these x values are the solutions to this equation. How did I get these values? So if I look at the general solution, I'm calling these two solutions are these general solutions of the equation that I have written here. So if I substitute n equals to 1, then x equals to pi by 3 plus 2 pi. I'm working with the first one. If I substitute n equals to 1, then I get 7 pi over 3. I'm just adding these two numbers. Or if I substitute n equals to 1 to the second expression, x equals to 2 pi plus 3, 2 pi over 3 plus 2 pi, then I will be getting 8 pi over 3. And if I substitute n equals to higher values, I will get other angles, other x values that will satisfy this equation. Similarly, I can also substitute the negative n values to get the values to the left side of the x-axis. So that's how this is the basic idea of trigonometric equations. Now we'll solve one or two or maybe a few more problems uh, to see more details. First one, let's solve the equation. Solve the trigonometric equation. 3 cosecant x plus, not plus, sorry, 3 cosecant x equals to 4 plus cosecant x on 0 to 2 pi. So note here, we have to find the x values that satisfy the both sides. That means we will get the same value if we substitute the value of x to the left side and right hand side. We'll get the same value. That's what we have to do. We have to find x values in this interval, and this interval, it includes 0 degree or 0 radian, sorry, includes 0 radian, but it excludes 2 pi radian. So we have to find the angles between these two values. So let's solve this. So 3 cosecant x equals to 4 plus cosecant x. So if we consider this cosecant x just as a single variable x, then we can see that 3x equals to 4 plus x. That means we have same thing in the both sides. So then we can just uh, subtract 1 cosecant x from both sides. That will give you 3 cosecant x minus cosecant x equals to 4 plus cosecant x and minus cosecant x. So this 2 cosecant x from the right side will cancel each other, and then we'll be left with 2 cosecant x equals to 4. Now we have constants both sides, and then we can just divide both sides by 2. We get cosecant x equals to just 2. Now, one more time, if we look at the unit circle, if this is the unit circle, we know the angle pi over 6. If we consider this angle pi over 6, the ordered pair, the component here, the first component will be root 3 by 2 comma 1 half. And if we consider one more angle here, the coordinate here will be the same number except the negative value for the x coordinate and y is positive. So here the first angle is pi over 6, that gives you sine x equals to 1 half. And using the reciprocal rule, we know that cosecant x equals to 1 over sine x. So using this property, we know if x equals to pi over 6, cosecant x will be 2. So from this line, we can write this implies that x equals to either pi over 6. Now, in order to find the other angle, let's say I don't know what is the measurement of this angle. So how do I find that? So if I subtract this angle, pi by 6 from pi minus pi over 6, I get pi over 6. So the bigger angle here is 5 pi over 6. So these two are the solutions of x. We can write the solution of x as a set. So the solution set, let's say the set is S equals to x belongs to R, such that x equals to uh, pi over 6 and x equals to pi over 6. Or simply we can just write s equals to pi over 6 and pi over 6. Both forms are acceptable. All right. So let's solve one more problem. Uh, let's say we have this equation root 2 cosine x plus 4, oh sorry, it's plus 5 equals to 4. We have to find the x values on real numbers, set of all real numbers. There is no limitation of intervals. Okay, so similarly, we just can subtract 5 from both sides. Then we get root 2 cosine x plus 5 minus 5 equals to 4 minus 5. From here, we obtain root 2 cosine x equals to negative 1. And then we can divide both sides by square root 2, and we get cosine x equals to negative 1 over root 2. So one more time, if we look at the unit circle, if we look at this unit circle, we know cosine x is negative in second quadrant and the third quadrant, where cosine x is negative. In the first quadrant, cosine x is positive, and in the fourth quadrant, cosine x is also positive. So in these two quadrants, it's positive, and in second and third quadrant, it's negative. So Assume that we have cosine x equals to positive 1 over root 2. So in that case, the angle here, it will be simply pi over 4. The symmetric angle in the second quadrant is somewhere here. And how do we find that? Well, this is 1 pi over 4. This is 2 pi over 4, meaning pi by 2. This is 3 pi over 4. For simple pi over 4, the quadrant here is 1 over root 2, comma 1 over root 2. And in the second quadrant, the coordinate here will be negative 1 over root 2, comma positive 1 over root 2. And in the third quadrant, it will be negative 1 over root 2, comma negative 1 over root 2. And to find the angle, we calculate the multiple of pi over 4. This is 1, this is 2, 3, 4, and 5. So our angle that satisfies this equation will be x equals to, the first one is 3 pi over 4, and the second one will be 5 pi over 4. Now, since we have to find the solution on real number r, that means we should not stop here. We have to find other x values that satisfies this equation. Cosine x equals to negative 1 over root 2, or simply the original equation. So in order to find that, we see that if we move simply pi from this position pi, we get another values. So our solution would be something like this: x equals to no, sorry, it should be something like this. The solution set s equals to x such that x equals to 3 pi over 4 plus 2n pi, comma x equals to 5 pi over 4 plus 2n pi. Oops. So this is the solution of this problem, where you should write n belongs to all integers. So that's how we solve this. To verify, you can substitute n equals to 0, 1, 2, or negative some integers. Let's solve one more problem, and that's the end of this section for now. Problem 3, 8 cot x, 8 cot twice x, twice x minus 5 equals to 3, and we have to solve this on 0 to 2 pi. Same as before, 0 included, 2 pi excluded. So let's start with the given equation. 8 cot twice x minus 5 equals to 3. We can add 5 to both sides. Then we get 8 cot twice x equals to 8. And this resolves cot twice x equals to simply 1. So again, we know tangent and cotangent functions are positive only on first quadrant and third quadrant. So if we draw the unit circle again, let's say this is the x-axis 0 and the y-axis. At 45 degrees angle in the first quadrant, cotangent is positive, and at this angle, this is 5 pi over 4, 5 pi over 4. Cot function is also positive. So our solution, our general solution will be something like this. So twice x equals to uh, pi over 4 plus n pi. Note here, in our previous problems, we added 2 n pi for the general solution. Why we're adding n pi here? The reason is if you move to the counterclockwise direction pi over 4 distance, angular distance, you will get here, and the coordinate here for coordinate will be 1 over root 2 comma 1 over root 2, and if you take the ratio to these two numbers, you'll get the value of cot functions. Cot equals to cosine over sine, and you will get positive 1. If you have 5 pi over 4, if you have moved 5 pi over 4, you will get to this point, and the coordinate here is 1 over negative root 2, negative 1 over root 2 comma negative 1 over root 2, and if you take the ratio, the quotient of this number up to these numbers, you will get positive 1 again. So from here, from this point, let me send the color. From this point, I just have to move pi distance, angular distance, to get to the other solution. That's why we're adding n pi. Okay, so now to find, well, we can also simplify the above line here. The x equals to pi over 8. We're dividing both sides by 2, and this is n pi by 2. So to find solutions, to find solutions on 0 to 2 pi, we have to substitute n equals to 0, 1, 2, 3, and some other positive values. Why we're not taking the negative values? Because the interval itself is positive, so we don't have to worry about the negative n values. So let's substitute n equals to 0, then we get x equals to simply pi over 8. If n equals to positive 1, we get x equals to pi over 8 plus pi over 2, and if we add these two numbers, we get 5 pi over 8, and if we substitute n equals to 2, we get x equals to pi over 8 plus 2 pi over 2, which is pi over 8 plus pi equals to 9 pi over 8. It is still in the acceptable range because it's not outside of this range. So now we have to keep going this way. N equals to, if n equals to 3, then x equals to pi over 8 plus 3 pi over 2. Then we get, if we add these two, we'll get 13 pi over 8. If you calculate this in degree, you'll find some degree values in between 0 to 360 degree if you are not comfortable with radians to see if it is inside this range. Now, if we consider n equals to 4, we'll get x equals to pi over 8 plus 4 pi over 2. This is pi over 8 plus 2 pi. We don't need to calculate what this addition results because it's already beyond the range, because our angle has to be between 0 to 2 pi. We cannot go further. So our solutions will include the x values up to this point. So the acceptable x values, the first one is pi over 8, the second one 5 pi over 8, The third one is 9 pi over 8, and the last and final one is 13 pi over 8. So we'll write our solution set as like this: s equals to pi over 8, comma 5 pi over 8, comma 9 pi over 8, and 3 pi over 8. I'm sorry, it should be 13 pi. That's all. We'll continue in the next video. Thank you for watching.